That was the purpose. That why he bought it.
He just crossed it.
Running it somewhere.
It's up there. Yeah, he just crossed it.
Okay.
And
There it is.
Yeah.
Looking and it didn't fall down. They need to fall down.
So you see that.
which one was it?
Go to Hive. Click on Hive. Go to Hive Metastore. You see. So that's how the MySQL is used. You can change it to Oracle in the configuration. So any questions on Hive interface so far?
How did the metastore get created? Yeah, was it the create table commands we did earlier?
Okay.
How did the metastore, how did the metastore with the schema information, or the pseudo schema information get created? Is that the create table we did earlier?
Yeah, we created it first step. If you look at the folder, they create tables. I'll show you that.
Right.
Yeah. This one, if you look at, open it up, create tables.
it's saying
It's where you created it.
it's almost like create this table.
But where does, okay, so you're doing, okay, so that's
Yeah.
fields in the same order.
Yeah.
It's like a Oracle. Okay.
You know what, that is funny.
Basically, sure they use my scores.
All these are referred to as external.
Yeah. All of them.
And if it's binary data that needs special manipulation, tie that in.
Yeah, you know it better, right? How the binary bits are managed and what data type they are, zeros and ones. You know a schema. You created a file in Hadoop file system that way. Then you go back and create a table like that. Then you can map it in SQL and use it. So it's all about how the file is structured and you know it better. Right? So that's how we use it. And storage, if you look at, if I go back,
It's very
let's say store a text file. If you pay attention, I say it's a text file. There are other combinations available, binary and stuff. So you can use that to store different format.
And so earlier when you're asking about this, so this is what's nice, you're just storing it as a flat text file,
Right.
and put the SQL overlay onto it to run
What
SQL.
if you have a strangely formatted binary?
Binary object
Is there a
map.
way to put a filter in that will let you
People store Java serialized objects at all.
let the metadata understand the strange format?
So if you don't have it, then you can do it for me. Yeah, you can use it. You can either do regular transform. Basically, there's obviously
Oh, sure.
Especially here in
especially for the exploitation statement, you can jump up in that one.
Here. You want a bigger one? No. That's it?
array statement is a lot like SQL.
What is he going to repeat? Repeat the question.
So we are going to run some raw map reduce. So everybody has to be in a specific folder. You have to be in this folder. Yeah.
Next one.
Right. Yarn. So yarn we call yarn. We're not really running the yarn. We are running the raw map reduce, which interacts with the yarn. Then I'm going to show you the code. How do we manage the mappers, reducers, and how do I do some specific partitioning using a raw Java map reduce code.
So what's the purpose why we are trying to run raw map?
Yeah. The question is, why I want to do that? Because I want to take control. When I do hive and peak, it does. I want to specifically store a certain pattern file in certain folder. I want to segregate the data type and by content. Then you go for raw map reduce where you have full control what you're doing. Right? So, yeah. So go ahead and run it. Run yarn yarn.sh.
You might want to mention when you have the R as the first line of your scripts.
Yeah. So you saw the RM script in the beginning of the file. If I have to repeat this again, I'm going to remove that folder, rerun it and create just a facility so that you run it successfully every time. Because if you don't do that, it says folder already exists and you get an error. So nothing to do with your job because folder already exists. So I remove that folder so that I can run this job every time successfully. So in every script, I have a remove command so that you can repeat it and execute it.
This is really heavy.
Yeah.
So on the mapping, so why does it have to
So is all of the basically
so many different steps for mapping and the data is in one location?
I'm going to extend that.
Java like
Yeah.
I mean, it's all a matter of how good case lists. And there are other Java
Get out.
I'll let you talk. I can't. We're on together.
03 yarn.
The yarn job successful.
So I need to run this one?
Yes.
That's not. That's it.
Could I ask you something?
Yeah.
When we shut down the hive, it said the test says you were in the hive problem. I did control C to come out of it. Because closing down test session. Why did it say so?
I think maybe the name of the job. Go and check in the shell script. Maybe they named it test.
But I thought these two are two different technologies. Like the hive and test.
Yeah, stage. Okay. Yeah. So if stage is the one that's running the map reduce for you, right? So when I send a request from page or hive, it goes to page. Page is running the map reduce for you. So it takes a session. Yarn is a resource negotiator. He's not a raw map reduce. He's not doing any hand coding here.
So test speaks to Yarn.
Yeah. So Fetch is an execution engine. Yarn is a resource manager. It manages the resource in a cluster. So when you run something, the request goes to Yarn. Yarn assigns a container. Oh, you can go and use this particular cluster, this data node, or spin up a new container like a JVM run it. So it's purely a resource negotiator. So Yarn is a resource negotiator. Fetch is the execution. Right. So if you look at this particular folder here, Yarn created, right?
So, yeah, those are basically higher level.
There are like 12 files, 12 folders or 12 files created. Right? See, that's how, if you look at this particular file name, part 007, if we are part of the same file, we don't know which part of the file it is. You loaded some file, whether, right? The HDFS names this like this because it takes a chunks of the file and distributes across the cluster, and it has its own naming convention. So the name node maintains all the mapping to your file. How many chunks of these are mapped to file that you loaded in HDFS? So this is the typical file you see in the HDFS when it's processed.
Syntax of the Hadoop command you use for that?
Okay. Maybe I'll just bring it up and clear it up. So I just count the line. I type it into a line count WC.
But there's an underscore success that's 0 bytes. I think that's
Yeah, that's a flag.
So then that 12 include that.
So that's what.
Include that one.
Yeah. We may not need to only maybe grep for grep minus the success.
What's after 2013?
Oh, small.
That doesn't.
Yeah, but on the first line you see success. That's a kind of indicator for a job runs success, right? So then usually this is attributed to your monitoring stuff. All the monitoring tools on Hadoop look for this particular file, whether job ran successfully or not. If it doesn't find the success, it's going to report the error. So it's just an indicator. And rest of all the files that it created. See the part files everywhere. So this is the part file that creates.
So sometimes, what's the 003, right? And, when we ran the fake, I had 005, right?
Yeah.
How do I know how many part files are the 003?
So you don't have to know.
So it's not under my control.
Yeah, you don't have to know. Yeah,
But you did say that something about the 64 MB or 128 MB.
Yeah.
Has it got anything to do with that?
Yeah, it does. Yeah, it does. Block files. There are blocks of files.
Okay.
Yeah, it applies that rule here.
I see.
Yeah. So every partition, every part of the file, either 64 or 128 MB. The question was why, then, and what is the how it is stored in a block size, 124, 128, 64 MB block size. So you're asking like, how can I take control of certain aspects of MapReduce? I want to look for a pattern in the file, and I want to push that pattern to one particular file set folder, particular reducer, right? So when you run peek and hide, you never had a control. The Hadoop did whatever you want. So if you want, suppose, a specific zip code in a file, I want to move to only one file. So I want to categorize by zip code or city name or something. So you want to take control of that. If you look at this particular code in the reducer, I look for their beginning number, the particular token which started 0, 1, 2, 3, 4 in a weather file. So whenever I say return 0, if you look at when I ran the map, it creates 9 reducers. I said create 9 reducers. I am telling you why. So if you look back to this particular screen, here there are like 10 files, or 10 or 9 files, right? You go in one of them.
There is 0 there, right? It's 10. Yeah, 0 to 9.
You see the beginning of the letter number, it's all 9.
Oh, you can.
All 9 here,
That's the sensor code.
right?
Yes, sensor code.
So what did I do? I separated any line that begins with letter 9, go to one particular file. Anything that with number 5, go to a particular file folder in the file. So how does it help me? So I can map this format to my Hive table. I can process a specific Hive table, a specific partition, a specific data type. So it becomes easy for me to maintain it, manage it, right? Instead of mixing everything, one shows 9, 8, I can take control of how my file is divided in Hadoop. So that you can do with Yarn raw MapReduce. So look at the code. So this is the reducer part. So when I map the file, when it comes to reducing, I say, look at this particular digit in the beginning and send it to one particular reducer that's running. So anything that begins with the file 0, line 0, always goes to one particular reducer. That reducer creates a file. So every reducer creates one file. Every reducer creates one file. So I can focus what I want and who manages it. Right? This is one of the aspects of raw MapReduce. For this, you need to understand how the Hadoop framework is built in Java, what kind of classes, what kind of interface we need to inherit, implement, all those things you need to know. So basically, we use this one when you want to do some products. You want to build a product on Hadoop. People go developing raw MapReduce jobs. Or if you're doing some data analysis, you don't have to go this way because you can expand your cluster, you have more cluster, more capacity. then you can use a Hive or a Pig or any other tool that runs on top of Hadoop. So you don't want to go this route because it's very complicated for a normal user. So usually this approach is taken when you have products built on top of it that you want to productize. You have specific data that you always, like sensor data, weather data, stuff like that.
So out of the box, it's the default.
Which one? Yeah.
This is what it comes with, the Hadoop distribution, any distribution.
No, this is a custom code.
With a custom code.
We built this one.
But
It's a hash partitioner that comes out of the box.
Yeah.
Out of the box.
Default
All
one.
the box, yeah. It will be very random. It doesn't really focus. I cannot tell. We start with 0, go to 0.
okay,
It just does random.
that's random, is it?
Random. Now I can focus it. Then you need to write your personal code for this to make it happen. So this is a specific code that we built together.
Yeah. And its default is random because normally you'd worry about hot spotting for where it's getting wrote. So this allows you to put them into directories if you need the control to organize how your directory output will be.
Okay.
But then if you go back and try to pull data on a time basis or something,
Yeah,
then
so-
you're paying.
No, because remember, this is still an overlay. The actual file system is still distributed across all of it. This is just a directory structure on the overlay.
See, it's for our convenience, right?
Yeah, it gives you another tool to exploit how
Is
the
this a
platform
partial,
works.
is this another copy of the data?
It allows you just to partition the data in the directories so that you can focus, like you said, if you do Hive, and you're partitioning in Hive so that you don't have to sort the entire population, and you can get the date range.
Okay.
It allows you to do that, similar to the way the partitioning happens in SQL when you go in and do that.
And if you look at the code that runs the shell script, if you look at, I said 64 MB block size, split size. You have a bunch of files, but every time a mapper maps it, take a 64 chunk and give it to the reducer, right? So you have a large number of small files, then maybe you want to increase your block size. So I can say split this by 64 MB or 128 or 256. Let's change it to 128 and rerun it again. So go to shell script, change it to 128.
What happens by mistake if I set 72?
72?
Or some random number.
It takes 64, it maps, it goes across the border, right? So mapping, then there's overlap of reducers. Then they have to sort it out, get the right data. There will be overlap, right? So that's you have to be careful.
And what's the max split size?
Usually 64, 128 or 256 can do.
And that 256 what?
MB.
Okay.
Yeah, that's assumed. Yeah,
Yeah.
you know, not 264K.
So you'd adjust that mostly for your problem space and the hardware that you have.
So it won't split the input file. With the input file, let's say you reach 60 meg, right? 60 kilobytes,
Yeah.
right? 60 kilobytes. It won't fit in the next one if it's starting off a new one. It knows 64. It's not going to split that file. It's going to make sure it can fit in the 64. The next one will start.
What if they're all bigger than this block? Then you'll start again.
Then you need to come up with a newer size than 64. Pick the bigger size.
If they're all bigger than a block and you're using the whole file,
Yeah.
it'll be the size of the file then, and it'll just stop as soon as it can.
That it is 64 megs, not
64
K.
megs.
Yeah. Script. We change it from 64 to 128 right here. Go ahead and change it and run the yarn job again. And do you see any change when you run the, you see the log? It's going to reduce the number of reducers because your file size is bigger. Now one reducer can handle more data. So number of reducers reduced because you're reading more chunk in one shot. Instead of 64, you're reading 128 MB. So reducers are reduced. Now reducer can handle more data, where more data is coming in the pipeline. So I don't need 10 or 12 reducers, I can work with a lesser reducer. But so now it's going faster. Percentage of completion is faster.
Can we change the number of?
But it's still going to create 9 files or 10 files.
So
We didn't change
changing
that.
that block size.
We didn't change it.
No, the reducers are saying you got a lot less math to make larger block size. So the cost of overhead is set. Standing up math is
See, the reducer start kicking here. Until then it was only mapping. Reducer starting from here.
The lights are faster than Apple.
Yes, Intel too.
The same 9.
You see, it's cheaper.
Yeah, so that's driven by the reducer. So each reducer will write it.
I say I'm sorry.
Zero.
Maybe a 2.8.
And larger block size.
Less mappers on structure.
They're relevant.
Because it's data it costs more to stand up the data and tear it down. So you want to get a good chunk of data, and like get them all running between a minute or 3 minutes.
Plus, there's a limit on. In a small environment like this, we're going to run that.
On the real machine, most of the time it's right. You basically make a map. You can hear it. Never thread inside of that.
For logic.
Even having
Yeah, so depending on your workload,
Like an i7, it has 4 cores.
so sometimes you get no benefit out of that. Except for a lot of the tuning the cluster. So it's going to depend on what your workload is, if that's valuable to you or not. But for the most part, it started out with physical cores.
So you guys see the change? Did it complete faster? When you change it to 128 MB, you can change your computer. It's faster, but it has one. I told you.
Yeah, you'll be on a certain
So, do you see any significant difference? You know, I know each machine has different configurations, but relatively it should finish faster.
It is relatively.
Faster, right? Yes.
It's still true that underlying knowledge of the hardware is important in massive applications.
If you see, go back to the shell script and see we have a split size, that's the input split size. Then I say reducers. I can assign how many reducers can work at the same time along with the split. Right? That depends on your cluster configuration. So there are so many parameters come into the picture. What's the length? How many reducers you can spawn? How many jobs are running? Right? There's some kind of rough calculation that you need to do. So it comes with your cluster sizing. Right? So there is a math behind it. When you do a raw map reduce, you have some kind of formula that you need to apply to come up with the number of reducers, what kind of file, and how big the chunks are. So even if you try to reduce, maybe make it 8, number of reducers to 8 or 7, whatever number you like, try.
I think thumb rule is, I believe, it's number of data. Is that so?
We have only one difference. It's the resources. How many JVM containers you can spawn at the same time? Because every time you run a map reduce, it creates a separate JVM container.
Oh, okay.
So you can run multiple map reduce on the same. They don't interfere with each other's resource. They are siloed JVM containers. That's what Yarn does. Yarn does nothing but how many JVM I can run in this configuration. It looks for your cluster configuration and spins up those number of JVMs in your system to run your map reduce.
But what is this yarn.jar? Is that your code or
Our code, yeah, we custom code. You saw that actually.
So I would need to spin up my own yarn.
So it's not YAG, it's just I think it's a
It's a terminology.
terminology. You say actually map reduce job.
Okay, so it's a map reduce job you wrote.
So we don't control YAG here.
Can you show
YAG is self-control.
Can you show your map reduce code?
Yeah, part of it you saw I went from. So change your reducers and try making 8.
Take your water. You can have one.
You can have it.
It might take a while.
Takes a while. So you're not really using map reduce.
Change it to 1.
No, 8.
If you do one for the reduce.
I don't know. See, it sucks up all the data. Memory goes up. Maybe it will not be successful. So you don't have multiple. One thread is doing it. So probably it will fail.
It would fail.
Yeah, it will fail because if you don't have enough resource available.